Hey, welcome to another CASA Exploration Minute, in which I, CY the Science Guy, introduce to you, the viewer, what the heck an extravehicular activity is. This is brought to you by the Columbia Aeronautic and Space Association, so let's go ahead and take off. Let's start off with a definition of an extravehicular activity. According to NASA, an EVA is any activity performed by a pressure-suited crew member in unpressurized or space environments. NASA goes on to say that EVAs can provide an effective means for service, maintenance, repair, or replacement of space equipment without the need to remove it to a pressurized environment, return it to Earth, or abandon it. Right on. At NASA, underwater training changes depending on the EVA that is planned for the mission. This means that astronauts can learn anything from launching a satellite to making repairs on the space shuttle, all while on Earth, underwater. Here at CASA, we simulate weightlessness the same way NASA does. We go underwater. Remember, all scenarios are student-run and all props are student-built. At CASA, we simulate the repair of a damaged satellite. There are 3 components to our setup. Freeze it! Alright, let's take a closer look. The big blue thing on the right side of the screen is our simulated airlock. In order to enter space, all astronauts must first enter the airlock together. Just like no one can enter space without first being suited up and closing the hatch behind them, no one can leave the airlock tunnel until everyone is in and scuba gear is on and ready to go. The large white object with a hole in it in the foreground is the inflatable seal. It simulates an airlock malfunction that astronauts must fix. If they do not repair the seal to a T, there will be additional and more complex problems during the week-long CASA mission. The large white and gray object to the left is the damaged satellite. Our underwater astronauts must repair the satellite following instructions exactly as they have been written. Any mistakes in repairing the satellite will cause more than just technical problems during the week-long mission. Every year, the simulated satellite is sent a new communications dish. You may notice swim noodles attached to pieces of the communication dish. This is to maintain neutral buoyancy in order to fully simulate the weightlessness of space. Astronauts must assemble the dish in order to fully repair the satellite. If they do not, there will be, hey, you guessed it, additional problems during the week-long mission. In order to keep from floating away in space, astronauts use tethers. Here at CASA, we use easy-to-see yellow lines to simulate tethers. If one of our underwater astronauts lets go of one of these simulated tethers, they are considered lost in space. Thanks for joining us during this CASA Science Minute.